January 31, 2000. Puerto Vallarta International Airport, Mexico. 83 passengers and 5 crew members boarded a McDonnell Douglas MD-83, operated by Alaska Airlines. The flight was scheduled to depart Puerto Vallarta for San Francisco, then continue on to Seattle. Its flight number was Alaska Airlines Flight 261. The captain, 53-year-old Ted Thompson, had more than 17,000 flight hours, over 4,000 of those on MD-80 series aircraft. The first officer, 50-year-old Bill Tansky, had logged more than 8,000 hours on the same aircraft type. Both pilots had impeccable flying records. But as they prepared for takeoff, neither of them realized that a deadly flaw was lurking inside the aircraft. In an effort to cut costs, the airline had reduced maintenance and inspections, and the hidden problem on this plane would reveal itself just minutes after takeoff. At 1:30 p.m. local time, Flight 261 pushed back from the gate and began taxiing to the runway. The weather was perfect, light winds and clear skies. The first officer advanced the throttles, the aircraft accelerated, and soon lifted off into its initial climb. He hand-flew the plane during takeoff, while the captain handled radio communications. A few minutes later, as the aircraft climbed through 6,000 feet, the first officer engaged the autopilot. But soon after, the first sign of trouble appeared. As the plane reached 23,400 feet, a warning light illuminated in the cockpit. The autopilot could not move the horizontal stabilizer. Normally, pilots or the autopilot adjust the stabilizer to keep the aircraft balanced. For example, to climb, the pilot pulls back on the control column, raising the elevators, lowering the tail, and pitching the nose up. The stabilizer then adjusts to hold that attitude without constant pressure from the pilot. But if the stabilizer is stuck, the pilot must continuously pull back on the controls to keep the nose up, something nearly impossible to maintain for long. To reduce this workload, the MD-83's control yoke has trim switches that move the stabilizer, allowing the aircraft to maintain the desired attitude on its own. This adjustment, known as trimming, keeps the airplane stable and aerodynamically efficient. In the cockpit, the stabilizer's position is shown on an instrument. Nose down trim is displayed as forward and nose up trim as aft. The warning light meant the autopilot could no longer move the stabilizer. The crew began considering possible causes. Either the electric motor that drives the stabilizer had failed, or the stabilizer was physically jammed. They needed to find out which one it was. The first officer disconnected the autopilot to test manual control. The moment he did, he felt something very wrong. The airplane was severely out of balance. Because the stabilizer was stuck in a nose-down position, he had to pull back with about 23 kilograms, 50 pounds, of force just to keep the aircraft climbing. Clearly, no pilot could maintain this for the next 4 hours. They had to get the stabilizer moving again. The pilots pulled out the checklist and began troubleshooting. Airflow rushing past the jammed stabilizer at nearly 600 kilometers, 370 miles per hour, pushed the tail downward, constantly forcing the nose to dip, making the climb extremely difficult. Following the checklist, they tried multiple methods to restore stabilizer movement. They used the electric trim switches on the yoke, no response. They tried the manual trim wheel, still no movement. They tried both together, still jammed. Then they activated the backup trim system driven by another motor. Again, nothing. They checked circuit breakers, no electrical faults. Every switch was in the correct position. No matter what they did, the stabilizer remained stuck at 0.4 degrees nose down. The plane continued north toward San Francisco, and the crew still had no idea how dangerous the situation truly was. Deep inside the tail, the jack screw, the single component responsible for tilting the stabilizer up and down, was already dying. The threads between the jack screw and its acme nut had worn down after years of inadequate maintenance, leaving only about 1/10 of their original thickness. Part of the threads had already ground off and clogged the small gap between the screw and the nut. The remaining threads were moments away from complete failure. The rear of the airplane was, in effect, a ticking time bomb. But the pilots believed it was simply a motor malfunction preventing trim movement. The checklist contained no warning advising an immediate landing if the stabilizer could not be moved. To them, this seemed to be only an autopilot-related issue. They thought they could hand-fly the aircraft to San Francisco by keeping steady back pressure on the controls. When they finally leveled off at 31,000 feet, the pilots were relieved. At higher speeds, the force required to hold level flight decreased from about 23 kilograms down to roughly 4.5 kilograms. Still tiring, but manageable. They continued troubleshooting, alternating between the main and backup trim motors, trying different combinations, even using all systems together. What they didn't know was that each attempt only made things worse. Deep in the tail, the jack screw and its acme nut were being forced against each other like two tectonic plates under massive pressure. And soon, one of them would completely fail. As Alaska Airlines Flight 261 approached its destination, the horizontal stabilizer still refused to move. The pilots contacted Alaska Airlines Technical Center in Seattle, hoping the engineers there might offer a solution they hadn't yet tried. But the engineers were just as helpless. Aircraft often experience minor technical issues during flight, momentary glitches in the flight computers, failures in non-critical cockpit systems, or small cabin service problems. But this time was different. A limitation in the flight control system meant the safety of the entire aircraft was now severely compromised. The pilots began considering the safest option, an emergency landing at the nearest major airport. That airport was Los Angeles International, only a few minutes away. But when they discussed this plan with airline maintenance engineers and company dispatchers, the crew received not support, but pressure. The company wanted them to continue on to San Francisco. While the captain prioritized the safety of his passengers, airline management was focused on money. To them, the cost of delays and compensations was more real than the potential risk of a catastrophic failure. The company explicitly instructed the crew not to land in Los Angeles, arguing it would disrupt the flight schedule and cause missed connections. In hindsight, this commercial pressure was the same force that had originally led to cost-cutting and poor maintenance, the root cause of the disaster building in the tail. Now, that same pressure was pushing the captain to continue a dangerous flight. But the captain refused to give in. He firmly told the dispatcher he would land at the safest airport available. He would not risk passengers' lives just to keep the timetable intact. Thus, Alaska Airlines Flight 261 was officially diverting to Los Angeles. The pilots began preparing for the diversion while still struggling to free the stabilizer. They remained in constant communication with Los Angeles Air Traffic Control, the airline's operations center, and maintenance crews, attempting to regain control before landing. The flight crew noticed that when they activated the primary trim motor, The instrument showed clear electrical activity. This meant the motor was working, so the problem had to be mechanical. The stabilizer itself was stuck. The pilot decided to try one more time, using both the trim switches on the yoke and the trim wheel on the center console simultaneously. He hoped that combined force would break the jam. At the moment he attempted this, the already heavily worn jack screw threads, under extreme stress, finally failed completely. The jack screw abruptly broke free from its jammed nose-down position at 0.4 degrees and shot past the mechanical limits. The stabilizer swung into an extreme nose-down angle. The limiter at the end of the jack screw slammed violently into the Acme nut. In that moment, tragedy became unavoidable. Now, only the mechanical stop was preventing the stabilizer from moving even further. But the stabilizer was already far beyond its normal minimum position. The aircraft pitched sharply downward and began diving toward the ocean. The pilots desperately pulled back on the controls, struggling to raise the nose. The aircraft accelerated rapidly, descending at more than 6,000 feet per minute, about 30 meters per second. As the speed increased, the plane experienced enormous aerodynamic loads. Believing the aircraft was entering a stall, the captain ordered the first officer to release back pressure on the controls to recover. But the aircraft was not stalling at all. What was happening was far beyond anything the pilots had ever experienced. They could not understand what was actually occurring. Then, the overspeed warning sounded. The aircraft was now flying dangerously fast, risking structural failure. The crew deployed the speed brakes, which helped slightly, but the rapid descent continued. After fighting with nearly 70 kilograms or over 150 pounds on the controls, the pilots finally managed to pull the aircraft out of the initial dive. But now, the situation was worse than before. The stabilizer had jammed again in a new, even more extreme position. To maintain level flight, the pilots had to use tremendous force on the control column, and no one knew if the situation would deteriorate further. Air traffic controllers noticed that aircraft deviating from its assigned altitude and requested a status update. At that moment, the aircraft was at 27,000 feet. The crew reported they had regained temporary control and were slowing down to troubleshoot. For safety, they requested a block of airspace between 20,000 and 25,000 feet to test the aircraft's behavior. ATC approved. The crew monitored altitude changes and evaluated controllability. Since they could no longer fully control the pitch, the pilots requested both upper and lower airspace to be cleared to avoid conflicts with other traffic. In one last attempt to find something, anything that might save the aircraft, the captain handed control to the first officer while he contacted maintenance in Los Angeles. The captain explained that he had tried both the trim wheel and the yoke switches, and that the stabilizer trim is now fully driven into a nose-down position. But the maintenance staff did not grasp the seriousness of the situation. They simply replied, "If you'd like, you can try it again." By now, Flight 261 was isolated over the ocean at 20,000 feet, about 6,100 meters, with no practical options left. Pushed into a corner, the captain and first officer began planning for an emergency landing. They needed to test how the aircraft would behave if they slowed down, extended the flaps, or deployed the slats. If these actions caused the aircraft to lose control again, they preferred to discover it over the ocean rather than above the densely populated suburbs surrounding Los Angeles. Before taking any action, the captain decided to address the passengers. He activated the PA system and said, "Ladies and gentlemen, this is your captain. We're experiencing some control difficulties and are working to resolve the issue. We'll be landing at Los Angeles shortly, in about 20 to 30 minutes. Thank you for your understanding." The pilots began preparing for an emergency landing. The captain displayed remarkable situational awareness and calm. He requested that air traffic control allow them to continue circling over the bay to configure the aircraft for landing. If the plane went into another dive, they wanted it to hit the ocean, not the city. minimizing casualties as much as possible. The first officer then offered a critical suggestion. They should test the aircraft's landing configuration at their current altitude of 18,000 feet. Although the thin air at that height couldn't fully replicate low-altitude aerodynamic conditions, it still provided enough altitude to recover if the aircraft lost control again. Despite enormous psychological stress and physical strain, the two pilots cooperated seamlessly and stayed composed. They began slowing the aircraft. The first officer extended the leading-edge slats. The plane remained controllable, though the controls were still heavy. Next, the captain instructed him to lower the flaps. The aircraft was now close to landing configuration and still stable. At this point, landing immediately would have been the safest choice. But the captain decided to try one last time to unlock the jammed stabilizer. He knew that in the aircraft's current nose-up attitude, powerful airflow from below was pressing hard against the horizontal stabilizer, pinning it in place. If he could briefly pitch the nose up and then allow the aircraft to dip, airflow would strike the stabilizer head-on, temporarily reducing the pressure. At that moment, he could try to use the trim switches to restore the stabilizer to a normal position. If it worked, their entire crisis could be resolved. The captain called the lead flight attendant into the cockpit and instructed him to secure the cabin. Then he ordered the first officer to retract the flaps and slats. But the captain had no way of knowing the true condition of the aircraft's tail. The jack screw threads were already completely worn away. Even if the stabilizer moved, nothing remained to hold it in place. The first officer strongly disagreed with the plan. He urged the captain not to take the risk. Every attempt so far had only made the problem worse. Since the aircraft was still marginally controllable, the safest, most rational choice was to stop experimenting and head straight for Los Angeles. The captain paused, thought it over, and finally agreed. He instructed the first officer to extend the flaps again and prepare for the approach to LAX. At that moment, a loud bang erupted from the tail. Under the enormous aerodynamic load, the horizontal stabilizer tore free from its supports and snapped upward violently. The aircraft pitched sharply down and plunged into a terrifying dive. The pilots had completely lost pitch control. Any remaining hope of regaining stabilizer authority vanished instantly. But they did not give up. As the aircraft plunged toward the ocean at over a 70-degree nose-down angle, almost vertical, the captain made a stunning decision. If the aircraft insisted on diving, he would flip it over and make it dive upside down. The pilots forced the aircraft into an inverted position, flying upside down. Amazingly, it worked, at least for a moment. The nose began to rise. The 70-degree dive angle reduced to nearly 10 degrees. Flight 261 was now flying inverted. The pilots hung from their harnesses by their shoulders. The captain pushed forward on the controls, now inverted, to raise the nose. The first officer retracted the flaps and slats again, testing whether they could regain better control. The captain asked the first officer to help him push on the control column. Both men used all their strength, trying to bring the nose above the horizon. But commercial airliners are not designed to fly upside down. The most the pilots could do was slow the descent. If there was even the slightest chance of survival, they needed to get the aircraft upright again. The captain shouted for the first officer to help him push the left rudder to roll the plane upright. But because the aircraft was inverted, the first officer couldn't physically reach the left pedal. They both pushed hard on the right pedal instead, desperately trying to roll the plane back. It didn't work. Time had run out. The engines began to sputter and fail, unable to cope with the extreme airflow angles. The first officer deployed the speed brakes in one final attempt to slow the aircraft. But with the ocean rushing up at them, both pilots knew the aircraft could not be saved. At 16:19, Alaska Airlines Flight 261 slammed into the Pacific Ocean. No one survived. All 88 lives were lost in an instant. The greatest tragedy of Flight 261 is that it could have been prevented. Driven purely by corporate greed, Alaska Airlines had reduced maintenance intervals on the jack screw assembly. Its maintenance department often operated below standard. Critical lubrication procedures were frequently incomplete. On Flight 261's aircraft, the jack screw had been running nearly dry, grinding itself to death during flight. In fact, 2 years before the crash, a maintenance technician had warned the company about improper procedures, including falsified maintenance records. Instead of fixing the problems, Alaska Airlines placed him on paid leave. After the crash, the aviation world changed. Modern aircraft, except for the Boeing 737 MAX, have been redesigned so that a single-point failure, such as a jack screw malfunction, cannot cause a catastrophic loss of control. Flight manuals were updated to warn pilots not to repeatedly use a malfunctioning system. Procedures now mandate an immediate landing whenever severe control issues arise. Most safety recommendations ultimately targeted Alaska Airlines and the FAA, urging shorter maintenance intervals for critical components, especially tail control assemblies. To honor their extraordinary courage, Captain Thompson and First Officer Tansky were posthumously awarded the Airline Pilots Association Gold Medal for heroism. They chose to remain over the ocean rather than risk crashing into populated areas, saving countless lives on the ground and preventing an even greater disaster.